Hey guys, this is our section on similar and congruent triangles, so 3.6, okay? So there's definitions here. Similar triangles have the same shape, so they look alike. Congruent triangles are the same size and shape, so it's the same measurements all over. Just a kind of clue here. What we see here in this Venn diagram, you have the circle for all similar triangles. Okay? Similar triangles, congruent is embedded in there. Since they both have the same shape, they're both similar. Congruent is just a special kind of similar. Congruent, all congruent triangles, so this blue circle, are similar. But only some similar triangles will be congruent. A dilation, or to dilate something, means to make it bigger or smaller. You can think of your pupil. It gets bigger and smaller. If you get it dilated, they enlarge it really big, and that's why people have to wear like sunglasses after the eye doctor. So this is sort of an idea of what that would look like. You have this original version in the middle. Then I tried my best to draw a smaller version. I reduced the size. I dilated it down. I could also have the original and I could enlarge it, right? So it's the same thing as like a screen for a computer. I can make it bigger or smaller, enlarge or reduce the size of the screen depending upon the needs that I have. If you can dilate triangle A so it is congruent to B, the original triangles are similar. So if I take this little one, the reduced one I drew, and I blew it up, it laid on top of this perfectly, they were in fact similar. Notationally, triangle ABC is similar to triangle DEF. Remember, when we write triangles, we put the triangle out in front, ABC, and then this little squiggle is what means similar in this situation. So if you see that notation, it's similar. And then make sure we have corresponding parts. A should match with D, B to E, and C to F. They talk about a table. If you go into like the study section of your Apex, I'm just going to give you some numbers. Seems a little easier to me than flipping to the table. Corresponding angles. If I said angle A was 40, then I know, since it's written in the exact same spot, or not, we'll get back there. Since it's written in the same spot as D, I know D also is 40. And it's similar all the way down. So if B is 60, I know this is also 60. And if C is 80, I know F also is 80 because they are corresponding. And if you add all these up, you should get 180, and I know that is a triangle. So each pair of corresponding angles is congruent. So if the angles are written in the same spot, they need to be the exact same size if something is similar or if it's congruent. And similar triangles have congruent corresponding angles. So the angles need to stay the same. That's how you know something is similar, if the angles stay the same. The side lengths are where things can change. Okay? So you see the ratios over here. If AB is 16, D is 8, and this is actually a typo. This should be 10, or I'm sorry. Sometimes this thing kills me. Where'd it go? What the frick? There we go. Sorry. So this should actually say 20 and 10. This is 20, this is 10, and 12 and 6. What you're seeing happening here is that we have this common ratio between the two triangles. That's how we know they're similar. 16, 2 times, so 2 to 1, as big as 8. 20, 2 times bigger than 10. 12, 2 times bigger than 6. That's actually how I knew they had a typo here. So corresponding side lengths have the same ratios. They are proportional. Similar triangles have proportional corresponding sides. I'm not sure why they feel the need to repeat everything twice, but we're going to see where this doesn't work. So this is how we can really test similar. Angles should be the same, and we need to have these consistent measurements happening. So corresponding angles, like I just said, they're congruent. Swear to God, sometimes this thing drives me crazy. And the corresponding sides are proportional. Okay? And I'll just go ahead and kind of skip some of this, getting into some of the weeds a little bit more. And I want to look at the actual example here, where it's talking about, are they similar? And this is where I'll conclude. Okay? What I want to do is make these ratios. So in triangle AB, the corresponds to side DE. So that's 7 to 29. And the question is, are these triangles similar? So this matches with this. And I want to see if these are all the same thing. So next I would have 24. I guess I can do it in a different color, might help. So next I'm going to do this 24 and the 96. And finally the last side would be 25 to 100. And what you want to do, you can use your phone and you can just go ahead and divide these. So you can do the division and get what the decimal is. So this would be 0.25, and pull up a calculator. You should be able to kind of see these aren't going to be congruent because clearly, come on calculator, what is it, 7 divided by 29? Well, 7 divided by 29 would be 0.24. And this one, I believe, is 0.25 as well. But what that shows you is these are, in fact, not the same. This one is different. Since they are different, they are not similar. So all you're doing is setting up these ratios, these fractions, and simplifying it, and that should tell you if you're similar. Okay? I'm going to stop it there. That's a lot in one video, and we'll pick this up tomorrow.